Hi friends, welcome to Coordinate, and today we want to understand another type of a data structure which is called a queue, or let's just say queues as a data structure. In definition, professionally it can be defined as a set of elements of the same type in which the elements are added at one end. The other end where the addition is done is called the back, and the deletion is done also on the other end. The end where the deletion is done is called the front. It is likely different with a stack as a data structure, because with a queue you don't do all the operations, which is the deletion and the insertion at the same end. They are done at different ends. When we talk about data structures and algorithms, simply think of data structures in this way. Imagine you want to create a certain system, a certain software or an application, but you want to understand or you want to know on how you will be keeping the data or the information that will be being inserted inside your application or your system, the system you want to create. This is where data structures comes in. Is a way in which you plan on accessing and keeping the data that you want to store in your computing device based on the system that you want to implement. For example, you can ask yourself questions like, okay, in my cell phone, I have a phone book. How do I keep the contacts? Which data structure is applied on the phone book that I have on my phone? That is where data structures and algorithm comes in. I mean, data structure, the structure of data, the information that you keep before it is given to the people who you want to give it to. So that is definitely data structures. And with queues, you can tell that insertion is done at the back and the deletion is done at the front. Hence, the actual access pattern for queues, the actual basic pattern that a queue uses is called first in, first out. First in, first out, which we can of course shorten as FIFO. First in, first out. And a practical implementation or practical approach to queues is definitely what happens when you go at an ATM. Let's say in a bank. I don't know what type of bank you use, or any bank, whether traditional or anything, for as long as it is a bank with an ATM machine. So that is where we see practically how we can implement a queue. If you are accessing a certain bank, you can denote that the person that is at the front, we even evidently denote that that was the person that arrived first, and we don't expect the person that's on the far end, the very last end, to withdraw the money faster than the person that's on the front. No, that's how the queues work. First in, first out. If we were to do an illustration or to explain FIFO on a professional point of view, this is what we can do. So we have an ATM machine. Definitely this is an ATM machine. I don't know if it looks like an ATM or whatever. So let's say people start to line up now. They want to withdraw the funds from the ATM machine. So we have someone who came in first. He has also been given the ID as number 1. Then we also have a second person that arrived as second. He also has been given the ID as number 2. Then we had the third person. Then this is a queue, you can tell. Then we have the fourth person, the fifth, and the sixth one. Now, can you denote this now practically? Can we expect the person who's at the far end, the number 6th one, to withdraw the money first? Well, the answer is a no. Or maybe can we expect number 3, meaning the person that arrived at the third position, to withdraw the money first? Again, the answer is a no. The first person to arrive is the person that will withdraw the money as the very first one, and he or she will even go faster than the person that came last. First in, first out principle. Now in queues, practically in programming, the process of inserting elements inside a queue is what we call in queue as an operation when it comes to queues. Hence, in queue is simply the operation that allows us to add elements inside a queue. If we continue with the explanation of FIFO, we can say the person that came first in will also go out first out. It is actually the exact opposite of last in, last out. If you come in last, if you are at an ATM machine and you are number 16 as the last person, then definitely you withdraw the money last. You can't withdraw the money first compared to the person that is on the first position. So the first one has already withdrawn the money and he has even went out. So we have the second person again. You will follow the same syntax, first in, first out. We have number 3 again. He will withdraw the money and he will even go. Then from there we have number 4. He will withdraw the money and even go. Then followed by number 5. And then from there we have number 6 to do the withdraw. And then he also will even go. The process of removing elements from a queue is called dequeuing a queue. We dequeue a queue if we remove an element from the stack. So we've talked about 2 operations so far: in queue, which is adding an element, and dequeue, which is removing an element. So this is the practical approach to FIFO, which is first in, first out. Now, are there some other types of operations that we can talk about when it comes to queues? Well, definitely we have some operation. Another operation is front as an operation, because we've talked about in queue and dequeue. In queue, adding an element; dequeue, removing an element. So front as an operation, if we were to define, we can simply define, okay, this is similar to pick as an operation in stacks, because we've understood what stacks are as a data structure. If you want to understand what stacks are, please double check the description. There is a link that will take you back to what stacks are as a data structure in C++. So front, it returns the value of the element at the front without removing it. So the element at the front will be returned, it will be printed out, and it will not be removed from the actual queue. A queue, I mean, it's normal queue you line up. So let's say we have elements 45, 27, 63, and 74. So if we were to implement now the operation of front, so if we are now to see out the element, we say, okay, front should be printed out, then definitely we'll see 45. That is the element at the front, and it won't be deleted from the queue. So this is front as an operation when it comes to the queues. Another operation is the operation which is called isFull, or full as an operation. So isFull is an operation which validates if the queue is definitely full. It is a Boolean expression. Hence you will see, okay, is the queue occupied, fully occupied? If it is definitely occupied, I mean, yes, is full is equal to true. If it is not, I mean, if it is not fully occupied, then we need to return false, because it is a Boolean expression. Hence this queue are 45, 27, 63, and 74. If we are to pass in the operation is full, then definitely we'll see true, which is definitely a 1 saying, yeah, of course a queue is fully occupied. So this is another operation when it comes to the queues. Another operation when it comes to the queues is simply the operation is empty and size. Now size as an operation, definitely you can tell if we are to see its definition. This is an operation which returns the total number of elements in the queue. No parameters are passed inside the size as an operation, like we pass parameters in functions and anything related to that. So the size as an operation, it doesn't need to have any parameter in between the parentheses. Another type of an operation is the operation which is called isEmpty. It is used to check if the queue is empty or not. Then from here we can now denote the actual implementation that can be done. So if we want to implement a queue, we can either use an array or we can implement a queue using a linked list, just like it was with the stacks. If we want to implement the stack, we are using either an array or simply a linked list. So even on queues, if we want to implement, we can implement using an array or we can implement using a linked list. So let's progress on our next session as we now understand the practical implementation of these things. Now in the next session, we'll see how we can implement a queue using an array. Please don't forget to subscribe, and you are on CodeNet.